Om Swastiastu. Hello everyone, welcome again to my video. In this video, I'm gonna talk about transformation in mathematics. But before we jump into our topics, let me introduce myself. My name is Artha Mulyasa. I'm from 4B Mathematics Education class, and my last 3-digit ID number is 053. In this video, we will talk about transformation in mathematics. Commonly, there are 4 kinds of transformation. The first one is translation, reflection, rotation, and dilatation. Now, let's get started to the first transformation. So, the first one is translation. This type of transformation is defined as moving the object in space by keeping its size, shape, or orientation constant. So the formula for the translation is defined as A, which is a point x, y. And then this point translate with some translation value A, B. And then we got A prime is x plus A, y plus B. As you can see in the picture, there are 3 shapes. So the blue one is the original shape, and then this blue shape is translated to the right, and then it's represented by the orange shape, and it's also the same as the red shape here, which is a blue shape that translated down to where the red shape is belong. Next, we have an example of the translation. So the question is, find A prime if A is negative 6, 8 is translated with the translation value 3, 2. To answer this question, we already knew that the formula for the translation is A, which is a point x, y, translated with the translation value AB, and then it become A prime, which is x plus A and y plus B. So we already knew the value of x and y, and the value of translation value 3, 2. Now we substitute that in, and it becomes A negative 6, 8 translated with 3, 2, and it becomes A prime is negative 6 plus 3, 8 plus 2. And we calculate the formula, and then we got A prime is negative 3, 10. Okay, next topic is reflection. So a reflection means to flip a shape or function about a specific point. The shape or function will have a different orientation after the reflection, but its size and shape will not change. So this picture is represented what the definition of reflection meaning. So here we have a blue shape again here, and then in this purple line is represented the mirror or the reflecting line. So now we want to reflect the blue shape by the purple line or the reflecting line, and then we got this orange shape. As you can see here, the orange shape is like a blue shape that flip over here. So this part become this, and this part become this, and so on. Now this is the formula for the reflection. So there are many types of reflection, and these are the formula on the middle table, and the right side table is the matrix. And if you can see here, we have these two formula, which is line x is equals to h and line y is equals to h. In the formula we have 2h minus x comma y, which is the a prime. So maybe you wonder why there is 2h in this formula, not like the other formula. So I will explain a little about it. So suppose we have a Cartesian plane like this, and then we have point in here. Now we're gonna label it as h, and then in this point we draw a line like that, and then now we have a point here and here. Now we label it as a x1 comma y1, and then this will be y1 and this x1. So as you know before, the reflection is keeping the distance from this point to the mirroring point, and then the prime point will be the same distance as the original point. So now we want to calculate how many distance in this A point or point A from the reflection point. So we get that by h minus x1. Okay, so these are the distance from the point A to the mirroring line. Now if we want to find the A prime, which is the point after its mirroring, simply we're just gonna add this distance with the point h here. So suppose it here, and it will become h plus h minus x1. So there you will have 2h minus x1, just like in the formula, and the y will still remain the same here. Now to better understand about reflection, we have an example here. The question is, if point A is 4, negative 2 will be reflected by line x is equals to negative 5, find where the point A prime will be. So we're gonna use the formula that we already know, which is a point x comma y that will be mirroring by line x is equals to h, and then we got a prime is 2h minus x comma y. So we already knew that the point A is 4, negative 2, and the x value in the line is negative 5. So we substitute that into the formula, and then we got a 4, negative 2 that mirroring by line x is equals to negative 5, and then we got a prime is 2 multiplied by negative 5 minus 4, negative 2, and then we calculate the formula, and then we got a prime is equals to negative 14, negative 2. Now we are here in the third topic in this video, rotation. So a rotation spins a shape or a function about a given point. This spinning does not affect the size of a shape or a function. So rotation are considered a rigid transformation. So in this picture we can see how this blue shape again rotated, I think it's 90 degree to the right, and then it become this orange shape. So this point will be this, and then this point will be this point, and so on. And in rotation there are two formula if the center point is at 0, 0, or if the center point is at a, b. So if the center point is at 0, 0, we just gonna do the rotation as this formula in here. So I will explain a little about the formula. So if the center point is at 0, 0, we're just gonna rotate like this picture. That suppose it here is the Cartesian plane and this is the 0, 0. So we're just gonna rotate like this picture. So as easy as the using the formula. But if the center point is at a comma b, suppose we have a Cartesian plane like this, and the center point of rotation is here, a comma b. Now we want to bring the center back to the 0, 0, and that's why we're gonna have this back, and that's why we're gonna have a minus x, which is the distance to where a is gonna back to the 0, and it's gonna do the same thing at the b, which is b gonna be b minus y, which is the distance where the b point is back to 0. So that's why in this formula we have this section which is x minus a and y minus b. And don't forget to adding by the a comma b again, because that's are the original center point. So this is an example of rotation. The question is, a triangle were built by point P, negative 4, 4, Q, negative 4, 2, and R, negative 2, 2. If the triangle will be rotated by 180 degree and the center point is at 1, 2, find where the shadow of the triangle after it rotated. And to answer this question, we're going to use the formula where the center point is at a comma b. So this is the formula, and we already substitute the angle point, which is 180 degree. And then we continue to substitute the other value we already knew. And the first one is we count for, or we find the p prime first. So we already knew that the point P is negative 4, 4, and then we substitute that, and the center point is at 1, 2, and then we substitute that, and then we calculate, and then we got P prime is equals to negative, and then we got P prime is equals to 6, 0. And we will do the same thing for the point Q and point R, and then we got the point, and then we got the point Q prime is equals to 6, 2, and then the point R prime is equals to 4, 2. So the new triangle will be built by point P prime 6, 0, Q prime 6, 2, and R prime 4, 2. And this is the picture of the triangle before it rotated, and after rotated we're gonna get this triangle, and this is the center point 1, 2. So now we arrive at the last topic in this video, is dilatation. So this type of transformation expand or contracts the object by keeping its orientation or shape the same. This is also known as resizing. So the formula for dilatation is just like the rotation. There are two formula. The first is if the center point is at 0, 0, and the second formula is if the center point is at a, b. And the idea in this formula, which the center point is at a, b, is just the same like the rotation formula, which we have. Suppose we have a Cartesian plane in here, so this will be the 0, 0, and then we have another center point here, a comma b, and then we want to make it the center point. This center point a comma b will be 0 comma 0. So we're gonna have a minus x and b minus y, and then you calculate this and then you continue to calculate that thing with the concept of with the center point is at 0 comma 0 in here, and then after you get the value, don't forget to adding the center point a and b. So here we have a picture that shown a dilatation of a shape. So we have a blue shape here again as the original shape, and then this shape is dilated by some scale factor, and then we got this red shape here. So as you can see here, this blue shape just like resizing into this red shape. So this point will be this point, and this point will be this point, and so on. Here's an example of dilatation. So the question is line 5x minus 3y is equals to 15 will be dilated by the scale factor of negative 3 with the center point at negative 1, 2. Find the new line after it dilated. So to answer this question, now we first find the point that represented the line, because for the formula we calculate the point, not the line. So we have here we have the line is 5x minus 3y equals to 15, and then we find the represented point, and then we got a 3 comma 0 and b 0 comma negative 5. Now since it will be dilated by point a comma b, we are gonna use this formula as shown in this slide. So now we're gonna calculate the first point, which is a is 3 comma 0. So now we substitute the value that we already know, and then we got a x comma y dilated, and then we got a prime is negative 3 multiplied by 3 minus negative 1 plus negative 1 comma 3 multiplied by 0 minus 2 plus 2, and we calculate that thing. We're gonna get a prime is negative 13 comma 8, and we will do the same thing as the point A for point B, which is 0 comma negative 5, and then we got b prime is negative 3 multiplied by 0 minus negative 1 plus negative 1 comma negative 3 multiplied by negative 5 minus 2 plus 2, and then we calculate that, and we got b prime is equals to negative 4 comma 23. And after we got the new point, which is the point after it dilated, now we continue to calculate the new line. So we're gonna use this formula, and then we substitute the value we already got, which is the point a prime and point b prime, and we continue to calculate it, and we got the new line is 5x minus 3y is equals to negative 89. And that's all from me. I hope you understand what I'm trying to explain in this video, and see you in another video. Bye. Thank you.